I recently made a second channel repair pile video in which I worked through this big pile of faulty ZX Spectrums, giving them all a first look to see what each of them might need to make them work again. Off camera, I recapped a few which fixed their issues. That's kind of boring and not really worthy of a full repair video. But this one, 002, is a bit more broken, and I thought it would be worth taking a closer look. I've installed a transistor type composite mod, my new favourite method, and recapped the whole board. The voltages are all present, but before we get into fixing this machine, we should address the highlight of that repair pile video, which was this moment.
What's going on here? What the hell is going on here?
I often sing the praises of my Discord server, and so far it hasn't let me down when I've needed an explanation or help with something that's frankly above my level of expertise. Peter is my resident Sinclair expert, and he quickly worked out what this bodge is. Apparently it's added when the machine was upgraded from its original 16 to 48K. It's more normally seen in the form of a daughter board sitting in that socket, or sometimes as a pair of stacked sockets with the pin change made between those. Sinclair offered a mail-in service, and there were probably third-party repair shops where you could have your machine upgraded. I'd be surprised if this was a Sinclair bodge. My instinct tells me this was some enterprising independent repair tech that knew enough to be dangerous.
So what is it?
It's a good question. I'm glad you asked. To understand what's going on here, we need to talk about why there are different types of RAM installed in 48K Sinclair machines. And a superb explanation for this can be found on Phil Ruston's Retroleum website. Phil says,
4 varieties of upper RAM chip were originally used in the Spectrum 48K, 2 made by Texas Instruments and 2 made by Oki. All were sold as 32K devices, i.e. 32,768 bits each. In actual fact, these chips were intended to be 64K chips, but were found to be faulty during manufacturing. To avoid waste, they were sold as having half the capacity, i.e. 32K, with one pin needing to be set high or low to select the good page of addresses. Both Oki and TI chips are similar in this regard. However, the two brands have different bit cell geometry, which affects how they need to be accessed. Sinclair used jumper links to direct bus signals appropriately for the RAM chips on each board. Issue 2 boards were originally designed for TI chips only, and there is a single jumper link to select the good page of RAM cells, whereas Issue 3 and above boards have a jumper to select TI or Oki, and also for the good page of RAM cells. The part number on the chips determines the setting required. When using 32K chips, all 8 must be of the same type.
the original diagnosis by Paul was dead, which is 100% accurate. Powering on with the capture running results in no display output whatsoever. Plugging in the diagnostic cartridge shows a system in great distress. Scoping around, I find there is zero activity anywhere. No clocks. Address and data lines are either low or high. The reset signal goes high and stays there. Could be a dead CPU, or more worryingly, could be a dead ULA. The CPU is soldered to the board, but the ULA is always in a socket. Placing the suspect ULA into another working Issue 3 Spectrum results in... So the ULA is toast. That's upsetting. But there are modern replacements. I recently used the VLA82 in one of the charity new build machines, and Phil Ruston sells the Nebula ULA replacement on the Retroleum store. These have been a bit scarce in recent times, but I managed to snag one when good friend of the channel, James, owner of the Specky from Hell, or whatever he's calling it now, let me know there was some in stock. At £29 they are excellent value for money. Fingers crossed the availability will soon improve and we can get these without worrying about stock levels. For now, I'll put the ULA from the working Issue 3 in here and test with that. I've only just got this Nebula and I really don't want to break it. Right, so with a known good ULA installed, what do we get? Well, that's a display.
Ew.
And with the diagnostics. The screen says bit 7 is at fault, and the light on the diagnostic cart is also number 7. The lower RAM consists of 8 4164 RAM chips, which each represent a single bit from 0 over on the right, across to 7 on the far left. So this chip here, IC13, is probably the faulty one. ZX Spectrum boards are quite tricky to work on at the best of times, but probably one of the hardest things to do with these is to remove a chip soldered to the board. There are many pitfalls. The legs can be bent and twisted, making it hard to remove the chip from the board even if you remove almost all of the solder. The traces on the top side of the board are all bare, which means that any solder that does remain on top will be stuck firmly to them. Levering the chip up will result in those delicate tracks being torn from the board, something I've done a few times myself. I'm always tweaking my methods, but my current safest way is to remove as much solder as I can from the bottom side with the desoldering gun as possible. If the chip doesn't fall out of the board at this point, the temptation is to use manual force. A better method is to use some hot air to loosen the last bits of solder on the top side and gently pry the chip out. This still carries risk. It's all too easy to rush this. You're aware you might be putting too much heat into the board, which can also damage things. But it's important to be patient, gently nudging at the chip to check when it's properly free and only then remove it. And there we go. No damage. While the chip is out, it's a good idea to clean any stray solder from the top side. And solder wick is ideal here, but be very careful. Dragging hot wick over these bare traces can easily lift them. Don't ask me how I know that. Once I've carefully removed the excess solder and cleaned up with IPA, I visually inspect the board to check for damage or bridges. And then it's time to install a new socket, which is the easy bit. Before testing the board, I placed the suspect RAM chip in my trusty chip tester and... it doesn't appear to be faulty. Now, these chip testers are not 100% accurate, and you can sometimes get edge cases where the chip can appear either faulty or working, but it isn't. So the next step here is to put a tested good chip in the board and see if it passes the diagnostics. And... wait, what? The whole thing is dead again. Almost like the dead ULA is back in... oh no. So, how many of you spotted my massive mistake? Would you like to wind back at this point and see if you can spot what I did without spoilers? I'll wait here till you get back. So for those that didn't notice my mistake, what I managed to do was take the RAM chip out of the wrong board. Yeah, idiot. This one is the perfectly working issue 3 board I was using for testing, which is why it still has the bad ULA in it. So I removed this chip for absolutely no reason at all. Right, let's get this faulty chip out of the board, stick it in the tester, and...
oh, come on. Ow.
oh, right, well, this chip is also testing good. Edge case, anyone? New socket installed. Salvaged, good chip inserted. I'll speed up this test.
Oh.
So it's testing all this RAM as good, but there's this weird corruption on the screen, which points back at the ULA. Now, not all ULAs can be used in all revisions of motherboards. This issue 2 machine originally arrived here with a broken ULA which ended in -6, a later revision. These are the worst ones for failing in my experience. And the one from the issue 3 board is a... oh, that's a -6 too. So not a compatibility problem then. Well, my instinct here is to blame the ULA, which is nice and easy to test with the Nebula I did want to use. Oh well, that's what it's here for. Before I can use it, I need to change this old single wipe socket. They're terrible sockets anyway, but the Nebula uses turned pins for its legs, and they're just not going to fit into this type of socket. The old socket came out without any fuss, just losing one leg in the process, but no damage to the board. This machine is actually really nice to work on. The new socket is installed and the Nebula inserted. Diagnostics connected, switch on, and... it works! So is that ULA faulty? Here it is back in its original issue 3 board. How will this one test? Well, that works too, which is a bit confusing, but as long as it keeps working, it's all good. I'll make sure I give this one a thorough soak test and check to see how hot it's getting. These old chips can get surprisingly toasty. So apart from taking the right chip out of the wrong board, this went amazingly well. And as for the bodge, during testing for the faults, I tied the loose end of the floating pin to 5 volts with a bit of enamelled wire. Okay, that's about all I can tell you about the adventures I had with this machine. I hope you enjoyed my terrible mucking about, and I look forward to seeing you in the next one. Goodbye.